Picture this. It's the hottest day of the year. The air is so thick you can practically swim through it. The sun is just relentless, and the one thing standing between you and absolute misery, your air conditioner suddenly just goes silent. Yeah, we've all been there, or at least dreaded it. But what if your home was in a place that seemed scientifically engineered to destroy that very machine? Well, today, we're stepping into a true HVAC torture chamber. So, where are we talking about? This isn't some sci-fi scenario. It's the Texas Gulf Coast. For an air conditioner, this place isn't just a little challenging, it's an absolute battleground. These machines aren't just cooling homes. They're fighting a constant, multi-front war against a climate that is just incredibly aggressive. So what exactly makes this one spot on the map so uniquely hostile? We're calling it the Gulf Coast Gauntlet, and that's exactly what it is, a relentless assault from the environment itself. The threats here aren't just about high temperatures. They're a nasty combination of invisible enemies, all working together to break down even the toughest pieces of equipment. So, let's meet these attackers, shall we? Okay, so there are 4 big ones. First, you've got constant crushing humidity. We're talking 80% or more day in and day out. That forces these systems to pull gallons and gallons of water out of the air. Second, there's the corrosive salt air blown right in from the Gulf that literally eats metal components for breakfast. Third, you have these insane runtimes. These machines are on for 12, sometimes 16 hours a day for months on end. And finally, as if that's not enough, there's the shifting clay soil, which puts actual physical stress on the lines in the ductwork. It is truly a perfect storm of destructive forces. So how do these invisible enemies lead to a very visible and, let's be honest, a very expensive breakdown? Let's play detective here. We're going to conduct a little postmortem and look at the anatomy of a failure, breaking down the most common ways these machines finally give up the ghost in this brutal environment. All right, problem number 1, the frozen evaporator coil. This is the part that's actually inside your house, the bit that gets ice cold to cool the air. When it freezes over into a solid block of ice, well, air can't get through. And if air can't get through, your system stops cooling completely. We're talking a total shutdown. And this is where that nasty Gulf environment just pours gasoline on the fire. You see, in a drier climate, a frozen coil might be a minor hiccup. But with that extreme humidity, there is an endless supply of moisture in the air, just ready to freeze onto those coils at a crazy fast rate. The system essentially suffocates on its own condensation. Next up, let's head outside to the condenser unit. This is the big box at the fan that dumps all the heat from your house out into the world. But along the Gulf Coast, this unit is in a constant fight with the very air it's breathing, and that leads to some pretty catastrophic corrosion. You know, the speed of this attack is what's really shocking. This isn't some slow, gentle aging process. Now, this is an aggressive chemical assault. We're talking about systems that are supposed to last 15 years being critically damaged by corrosion in just 5. This decay tanks your efficiency, causes really expensive refrigerant leaks, and eventually leads to total failure. And that brings us to the heart of the system, the compressor. This is the engine that pumps the refrigerant through the whole thing. It is the single most expensive component, and you guessed it, in the Gulf Coast, these hearts are breaking down far, far too soon. Really, this one is a death by 1,000 cuts. A normal cooling season in most places might be 3, maybe 4 months. Here, it's closer to 7. Just think about that sheer, nonstop workload running for more than half the day, every single day, for months. It just grinds that compressor down, wearing it out years ahead of its expected lifespan. And all this leads to that ultimate dilemma, the question every homeowner with an older system eventually faces. You've just had one of these big failures. The repair bill is huge. Do you pay it? Or is it finally time to give up and replace the entire unit? When have you officially reached the point of no return? Well, the source material we looked at offers a surprisingly simple tool to help you make this very complex financial decision. It's called the $5,000 rule. And it's a quick little calculation designed to keep you from throwing good money at a dying machine. Okay, here's how it works. It's super simple. You take the cost of the repair, and you multiply it by the age of your system in years. If that number comes out to more than $5,000, the rule suggests that replacement is probably the smarter financial move. Now, it's not a hard and fast law, of course, but it's a fantastic guideline to figure out if you're investing in a future or just patching up the past. Let's walk through the example from the source just to make it crystal clear. Let's say you have a 12-year-old system, which is definitely getting up there for a coastal unit. The repair is going to cost you $500. So you multiply 500 by 12, and you get $6,000. Since that is over the $5,000 threshold, the rule flashes a big warning sign. It's telling you this system is likely not worth the investment anymore. It's probably time to start fresh. So, the key takeaway from all of this is that you absolutely have to prepare for the battle. Success isn't just about the machine you buy, it's all about how it's installed for the coast. Because a coastal installation, it turns out, is a completely different science. Let me show you what that looks like. I mean, just look at this comparison. It's night and day. A standard installation might use standard materials. A coastal install demands special corrosion-resistant coatings. A standard job might use basic duct tape. A coastal one needs professional mastic sealing to lock that humid air out. A standard install uses generic sizing. A coastal one requires a special calculation. It's called a manual J, to account for that massive humidity load. Even where you physically place the unit matters, positioning it to minimize exposure to that destructive salt air. Every single step is different because it has to be. And that really brings us to our final thought. This isn't just about air conditioners. It's a much bigger lesson in engineering and environment. From the phone in your pocket to the car in your driveway, we're completely surrounded by technology. But how often do we actually stop and ask ourselves, is this machine truly built to survive in my world? Is the technology in your life just visiting, or is it truly built for your environment?